Morning class. Today I'm going to do section 9.5 and 9.7. Okay. To begin with, let me do section 9.5, which consists of exponentials, base E, and logarithms, base E. Okay, this is section 9.5, exponential, base E. So y equals e to the x is section 9.5. Okay, section 9.5. Exponentials, base E, and logarithms, base E. So look, if you look at this, it's y equals e to the x. We can graph this. We have to remember that e, this is a constant, is 2.71. Okay? You can find this on your calculator. If you go to your calculator, you'll find e. Okay? Now, so therefore this is y equals to 2.71 to the x. And of course, e is not exactly 2.71. E is approximately 2.71. Okay? I mean, if we look at your calculator, I'm going to find my calculator, and I'm going to take a look at it, and I'm going to find E. I see E. In fact, I see e to the x. That's what I see. So if I press 1 for my calculator, and then I press e to the x, I get 2.7182. See? 2.17, 2.17, 2.712. Let me say it again. 2.718. 28. When 828 again, 1828. See, and it goes on forever and ever. Okay, so that's considered an irrational number. So we better, if we round to the nearest 10th hundredth, so this E is approximately 2.72. So we better write here 2.72 to the x. Okay? If you recall last time we said that whenever the base is greater than 1 in an exponential expression or an exponential equation, y equals 2.7 or y equals to whatever greater than 1, the base must be greater than 1. The exponential is increasing. That's right. So therefore this is increasing. This is increasing, and I can show it to you by a table. You can write x equals 0, x equals 1, x equals 2, x equals 3. -1, -2, -3. And I tell you the easy one, x equals 0, this is e to the 0, which is 1, because anything to the 0 power is 1 except 0 itself. And this is e to the first, which is 2.72, and e to the second is increasing, which is, we need a calculator. So let's go to the calculator, okay? So here we go. I'm gonna say 2 and then e to the x, and I get 7.39. And e to the third, and I get e to the third, and I get 20.09 or 20.1. It's increasing. And why is that? Well, because the base, this base here is greater than 1. Look at this. E to the negative 1. This is e to the negative 1. So go to your calculator, and I'm going to plug in negative 1. Okay, so negative 1. Make it negative first. And then e to the negative 1. And I get 0.37. So this is 0.37. E to the negative 2. 2, make it negative, and then e. I get 0.14. E to the negative 2, I get 0.14. Look, from negative 2 to negative 1, it goes from 0.14 to 0.37. From negative 1 to 0, it goes from 0.37 to 1. It's increasing. And e to the negative 3, okay, e to the negative 3. So here we go, write 3, make it negative, press e to the x. I get 0.05. 0.05. You can graph this and you'll see that it's going to be increasing. Okay? It's going to be increasing. So here's x, and this is y, and it's going to be increasing. Okay? Watch this. So if we say x equals 0, we get 1. X equals 1, we get 2.72. This is 1, this is 2, this is 3. So when x equals 1, 2.72, I'm going to say right around there. X equals 2, we get 7.39. X equals 2, we get 3, 4, 5, 6, 7, 8. X equals 2, we get 4, 5, 6, 7, 8, 7.39, and right around, I'm going to say right around there. Okay? X equals 2, 7.39, right around there. And x equals 3, we get 20.1, way up there. And then x equals negative 1, we get 0.37. X equals negative 1, we get 0.37. I'm going to say right around there, okay? X equals negative 2, we get 0.14. Negative 2, we get 0.14, right around there. X equals to negative 2, we get 0.05. X equals negative 3, we get 0.05, even closer. X equals negative 4, it's going to get even closer to the x-axis. And so therefore, the x-axis happens to be a horizontal asymptote for y equals e to the x. And it looks like this. So it's going to get closer and closer to the x-axis, but it's never going to touch there. It's like a plane landing. An asymptote is is like the landing strip of a plane that never touches ground. That's what's happening. This graph is never going to touch the x-axis, a plane landing, but it never touches ground infinitely. Never. So therefore the x-axis is an asymptote, horizontal. And because, listen, because it passes the vertical line test, this is a function, so we call this a function. Let's say f of x equals to e to the x. And if you want to, you can shift this function, you can shift it left, right, up, down. Okay. For example, if you say graph h of x equals to e to the x plus 1, this is going to shift e to the x, this graph, 1 unit to the left. Okay, so this point goes to the left, 1 unit. 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 And we get the following. So therefore, that would be h of x equals e to the x plus 1. Okay, you can shift it up if you want to. Sure you can. I don't have a different color, but I'm going to use black again. Watch this. I'm going to say p of x equals to e to the x plus 2. And what that's going to do is going to bring this dark f of x, is going to bring it 2 units up. Okay? So this point goes 2 units up. This point goes 2 units up. 1, 2. Okay? Every point goes 2 units up. 1, 2. Even the horizontal asymptote goes 2 units up. Okay, so I'm graphing this one now, and take this one, 2 units up goes there. This one, 2 units up goes there. This one, 2 units up. Okay, everything 2 units up, and this one goes 2 units up there. This one goes 2 units up, there, and so on and so forth. So now we're getting this. And this one goes 2 units up. There you go. That's e to the x. Now e to the x is connected, if you remember, e to the x is connected to the logarithm base e of x. They're connected. They are connected. Okay, so I'm going to leave e to the x here. I'm going to erase the other ones. I'm going to erase their graphs. Okay. Even this red one. Okay. And so here is y, and here is f of x e to the x right there. Okay, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and this is the graph for f of x equals e to the x. Well, this is connected. Yes, it is. This is connected to ln of x. Yes, it is. Okay, let me show you how this is connected. Watch this. Let's find the inverse. Find the inverse of f of x equals e to the x. Find the inverse. Okay. How do you find the inverse? 1, replace f of x with y. So y equals e to the x. 2, interchange x and y. So x equals e to the y. And 3, solve for y. And to solve for y, you need to bring this y power down. And so therefore, to bring this y power down, what you do is, you have no choice but to express this in terms of a logarithm. Now, if you guys remember what I said last time, what is a logarithm? A logarithm is an exponent. Always remember that. If you're walking on the street and someone comes to you and says, what's a logarithm? What are you going to say? A logarithm is an exponent. That's all you have to answer. Okay? Buster, you can say that. Okay? All right. So between the x, the e, and the y, this y is an exponent. So therefore, this y is a logarithm. This y equals to a logarithm, and that's the base. The y equals to a logarithm, and that's the base. Base e. This is the base of the logarithm. Y is an exponent, so y is a logarithm, and this is the argument. Okay? But whenever the base is e, class, whenever the base is e, we don't say log base e of x. That's not what we say. Whenever the base is e, we say natural log. That's what we say. And because the guy who came up with this concept, I think it was a French mathematician. Don't quote me on that, okay? So he would say log naturel. And so log naturel and the natural log, you just interchange the words. Okay? So log naturel, log ln naturel n. That's what we say ln. Although in English we say the natural log, but in French, log naturel. So, and because it came from a French person, well, okay, let's write ln. So therefore, we say y equals to ln of x. Nope, you don't have to show the e. It is understood that if you write ln, it's automatic base e. Okay? So therefore, so we have this, and so now we say, step 4, we say f of x, f inverse of x, because we're talking about the inverse. Look, find the inverse of f. We did, and we get ln of x. And if someone says to you, what does ln of x is, or what does that mean? You're gonna say ln is a the natural log of x. And then they tell you natural log, what base is it? What are you gonna answer? The natural log, you're gonna say, is base e. Okay? And so look, if you guys remember how to graph, or what the inverse represents in terms of a graph, all what the inverse does is it interchanges the coordinates. And that's why here, you see this y equals e to the x, this y became x, and this x became y. So you interchange the coordinates to find the inverse. So therefore here, if we interchange the coordinates, we'll be graphing its inverse. So okay, so what are the coordinates for this one? I remember this point here is 0, 1. How about the coordinates for this one? This one here is -1, comma, and then ln of -1. Okay, ln of -1. Actually, no, e to the -1. Let me write e to the -1. So, because I erased it. So, -1, make a negative, press E, and I get 0.37. So this is 0.37. Okay. And how about this one? Let's do one more, this one. I remember this was 1 and e to the first, which is 2.72. Okay, so this is 2.72. Okay, now to graph the inverse, all you need to do is interchange the coordinates. So this 0, 1 becomes 1, 0, and I'm gonna graph it in red. The inverse of this point is 1, 0. The inverse of this point is gonna be 2.72, comma, 1. 1, 2, 3, and 2.72, comma, 1, right around there, approximately. And this point here is gonna be 0.37, comma, -1. 0.37, I'm gonna say right around there, comma, -1 there. Okay, and so we're getting this. And so now this is the inverse of this one. And this is a function itself. Okay? This is the inverse. You can call this F inverse of x, which is ln x. But if you think about it, this is a function. It passes the vertical line test. Yes. This is a function. It passes the vertical line test. So you may call it by another name. It could be another name, okay? So you may call it g of x. Yes, you may call it g of x. You say g of x equals 2 ln x. Okay? G of x equals 2 ln of x. There it is, look. It's a function. The red graph is a function. It happens to be the inverse of this, but it happens to be also a function. All right? And this was section 9.5. I believe it's 9.5. Is letting us know. Okay? So now we have a function. Look. Now we got a function. And remember, it's the inverse of this. And this is what I said in one of my videos before, is that when you have a calculator, okay, you have a key with e to the x perhaps, and right up above, you should have ln of x. And up above, let me write it in red, okay? I'm gonna write this one in red. Right up above, you may have ln of x, and to get to ln of x, there may be a key somewhere here in red where it says second. And to find ln of a number, you need to press second and then this key. And it's going to give you ln of that number. For example, suppose you want to find ln of -3. Okay? I'm going to tell you how to do it in my calculator, okay? In my calculator, you need to go to -3 first. You say here, you press -3, okay? In my calculator, you need to press 3 first, and then you press the negative, not the negative sign, but a key that does this, a key that says plus minus. My calculator, okay? I don't know about your calculator. Once you press plus minus, it's gonna make it negative. Okay? And then, if you wanna, now you have this part. If you wanna press ln, you need to go to second and then press the key, because by going second, you're saying, okay, now second, I want the inverse of e, which happens to be ln x. Okay? So then you press second, and then this key, and it's gonna give you ln of -3, okay? And if you go to ln of -3, I'm gonna do it in my calculator. So negative, I'm gonna say 3, make it negative, and then ln. Oh boy. Okay. Do it again. 3, negative, and then ln. And what do you get? What do you get? You get what? Error. And why do you get an error? Because look, here is ln key. This is the ln graph. And you're pressing -3. Well, when you press -3, your calculator says, okay, in -3, I need to look up and down, and I need to find the graph when x is -3. And wait a minute, it looks up, I don't see the graph. Down, I don't see the graph for -3. Oh, it's an error. It's gotta be an error. Why? Because -3 is not in the domain. -3 is not in the domain. In fact, -2 is not in the domain. If you do ln of -2, it's also gonna give you error. ln of -1 is gonna give you error. Try it. And ln of 0 is also gonna give you error. Try ln of 0. Try ln of 0. And that's because this graph is never gonna touch this axis, the y-axis now. Just like this one does not touch the x-axis, but this one becomes ln, this graph. And if this one does not touch the x-axis, this one is not going to touch the y-axis. So if you plug in 0, if you plug in 0 into your calculator, the calculator looks up, the graph is not there. It looks down, the graph is not there. Why? Because this graph never touches the y-axis. So therefore, it's gonna say error again. Don't forget that. Okay? But if you say ln of 1, oh, that's gonna give you 0. You can tell right away. Well, try it. Try ln of 1 and it's gonna give you 0. Try ln of 2. Try ln of 2. And it's good. Now it's gonna give you a number. Yes, it will. Now it's gonna give you a nice number, right? ln of 2. Is it nice? 2 and then ln. Oh, I get 0.69. I get 0.69. 0.69, you see? Why? Because why you don't get error anymore? Well, because now if you plug in 2, it looks up and the graph is there. And it's 0.69. This height is 0.69. You see, this height right there, this height is 0.69 for 2. You can try it for 3 and you're gonna get this height. Try it for 3. Okay? So I'm gonna try for 3. Here's 3. Try 3 and then ln and I get 1.1. This height is 1.01. Okay, but if you try for -1, it looks down, no it's not there. It looks up, no it's not there, error. If you try 0, look up, I don't see the graph. Look down, I don't see the graph. When x is 0. When x is 0, you gotta walk down on the y-axis and you go down, 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 and this graph here never touches the y-axis. So therefore, you have no choice. The calculator has no choice but to say error. Okay. So this is the ln key, guys. This is the ln key. All right. Okay, so with your calculator, you can now plug in values for any value for ln as long as that value is in the domain. And what's the domain? You tell me what is the domain for the ln of g of x equals ln of x. What's the domain? Domain of g of x equals ln of x. What happens if you plug in -1? Not there. What happens if you plug in 0? The graph is not there. Not the red one. The red, I'm talking about the red one. This is e to the x, okay? And what happens if you plug in 0.1? Oh, the graph is there. Yes, it is. So domain of ln of g of x equals ln of x is going to be from 0 all the way up to infinity. And of course, let's exclude 0. And we're never going to get to infinity. If you start walking towards infinity, you're going to get old. I'm going to get old and I'm going to die, but I'm never going to get to infinity. So therefore, we always say excluded. That's the way we do it, guys. Okay. And so now we can plug in a few values into the, okay? And then we'll see if you plug in a few values. Let's do that, okay? As long as they are in the domain of ln of x, we're fine. Okay. So let's plug in, for example, let's plug in let's find ln of the square root of 2.14. Okay? This is positive. That's positive. It's not negative. It's not here. It's not 0. This is in the domain. We're fine. So let's find the square root of 2.14. Take your calculator, turn it on first. Okay, make sure you don't. There we go. Okay, so I'm gonna say 2.14, and I'm gonna take the square root. I see the square root right there, the square root. I'm taking the square root. So I got this part, okay, in my calculator. Your calculator may be a little bit different. And now I'm gonna press the ln key. Some of you may have to press the second. It all depends on your calculator, but I'm gonna press the ln, and where's the ln? I see it right there, and I get 0.38. Here I got 0.38. So this equals to 0.38. And so on and so forth. Okay, so this is the ln x key. ln of x key, guys. Okay, so let's go to the next section. Okay, okay, so the next section. Let me make two different videos, okay? So let me turn this one off, and then I'm gonna turn it on again, okay? Two different videos.